Okay, I'm going to try to work out this overall reaction for you. And remember, we start by trying to substitute a benzene ring, one of the hydrogens, out for an electrophile of some kind. I don't want to worry too much about what the electrophile is at this point or how we're generating the electrophile. I just want you to see the basic 3 steps in action. So before we get started, usually the electrophile is going to be generated, and that will usually be generated by combining an acid with something else, like a Lewis acid with a halogen, or nitric acid and sulfuric acid together for nitration, something like that. And then once you have that going, you'll add your benzene to it. And this benzene, even though it is, very stable, it does have a high concentration of electrons. So at one of these points, the electron is going to come and attack this electrophile. And just like with other double bonds breaking, you'll see that generates a carbocation. Okay, so here we go. I've added in all the hydrogens so you can kind of see it. These hydrogens don't go away at this point, but the electrophile is added on. So the electrons that made up this double bond right here moved over to form a bond between the electrophile and that carbon right there. So these electrons now make up this bond, but when this bond broke, there's no longer 4 bonds to this carbon, so that becomes a carbocation. Now, usually there will be some kind of nucleophile in the solution as a result of your generating the electrophile or the attack from the benzene. Don't worry about that yet, but just know that a nucleophile will come and take this hydrogen, just like you've seen in other elimination reactions, and then these electrons will restore that double bond and restore aromaticity. So now you can see that aromaticity has been restored and this hydrogen went away, so we substituted overall this electrophile for this hydrogen. The hydrogen down here, nothing ever happens. The only thing that happens is to the bond next to it. So that's electrophilic aromatic substitution. First, you generate in some way, shape, or form an electrophile. The benzene will attack that electrophile, creating a carbocation, and then it's just like any other elimination E2 or E1 elimination reaction. The nucleophile takes the hydrogen, those electrons fill in, and your aromaticity is restored. So when you're going over this in class and you're seeing this actually play out with different reagents, like you'll see nitration, sulfonation, halogenation, look for those 3 things. First, look for the electrophile to be created. Then look for the benzene acting as a nucleophile, attacking that electrophile, and the carbocation forming, and then look for the elimination step that restores aromaticity. I hope that helps. If you have any questions or if you need anything, drop them in the comments below.